answers then to this worksheet. I'll make it a little bit bigger on the screen. Okay. Some of these you had to look up because they are in the second half of our notes, right? So the breaking down of proteins to amino acids, glycogen to glucose, triglycerides to fatty acids, and glycerol is called catabolism. We're breaking things down from bigger to smaller. This reaction occurs when oxygen is added or hydrogen atoms are removed from a molecule. Oxidation, so that's a loss of electrons. Energy is what during oxidation reactions? Loss, because if we lose electrons, electrons are the energy molecules, or energy subatomic particles that are involved in chemical bonds, so energy is lost. And the opposite, energy is gained during a reduction reaction. Beta oxidation is the catabolism of what into acetyl coenzyme A? Fatty acids, very good. Oxidative phosphorylation occurs in the catabolism of glucose. Yeah, that's just a fancy word for cellular respiration and breaking down glucose. The blank is the primary organ that can interconvert nutrients. So that means it can change protein into glucose, fat into glucose. The liver, yep. The blank cannot store or produce glucose and needs a steady supply to function. The brain, yep. It lacks the enzymes. Number 9, blank are stored by the liver when glucose is absent. It results in fruity breath and can cause metabolic acidosis if it goes unchecked. Ketone bodies, yep. Triglycerides are made up of 3 fatty acids and glycerol. The electron transport chain in Krebs cycle occurs in the what of cells? Mitochondria. And glycolysis occurs in the cytoplasm of cells. The coenzymes important in aerobic respiration are NAD plus and FAD. They come from the vitamins. So if we say NAD plus, what vitamin does NAD plus come from? Niacin. And then FAD comes from riboflavin. Their job is to accept and release hydrogen atoms. The end products of glycolysis are 2 molecules of pyruvic acid. The starting product that enters the Krebs cycle is acetyl coenzyme A, or CoA, you can abbreviate it as. The part in the electron transport chain that actually makes the ATP is ATP synthase, with the help of protons pumped in from split hydrogen atoms. Number 17, the net ATP from the Krebs cycle is 2, and from the electron transport chain is 28, according to our textbook. It can vary by 1 or 2. When glucose is made from non-carbohydrate sources, such as, what are the foods we eat that are non-carb? Well, lipids and proteins, we can be a little more generic. Lipids and proteins, we call it gluconeogenesis. Neo means new glucose from non-carbohydrate sources. We're going to talk about that today. When excess hydrogen atoms are added to pyruvic acid, it forms lactic acid, and this occurs when oxygen is absent or reduced or non-sufficient, however you want to say it, but you could say absent. For a nutrient to be converted to another cell, for a nutrient to be converted to another, the cell must have proper enzymes. That's the buzzword of the week, is enzymes. And it's, well, I have a story to tell about that. in a minute. The nutrient that is least preferred to make ATP is, this is a tricky one. We'll talk about this. So in the body, we have the 4 major molecules in our food: nucleic acids, proteins, lipids, and carbohydrates. Which of those molecules do you think is most important for building the body and making enzymes, antibodies, proteins? Yeah, that's a really important molecule for structure and function in the human body. It accounts for, I think, 30% of the cell weight is protein stuff. So therefore, it's the least preferred nutrient, protein. So that's number 21. Sure, yeah. Yep, you could say amino acids, but it doesn't fit grammatically. Is protein would be the answer. Liver and muscles cells prefer blank rather than glucose for making ATP. Fatty acids, very good, very good. Okay, so keep this handy. This is a nice review for the whole set of lecture notes to prepare for the exam. And then also, if we go into Blackboard, you'll see that I also have a study guide for you at the bottom of the lecture folder. Here, we have a study guide on metabolism. So there's some questions to guide your studying. But don't get stuck like some students do where they only work on the study guide and they don't review their notes anymore. They just think that I'm, giving you a guide to the test. This is just a guide to get the key concepts from the notes. But you should still be reviewing your notes because not everything on the test is in the study guide, but it's a bulk of it. But you should still go into those notes to put the pieces together because this is kind of like fragmented questions. It doesn't show you the relationships between the concepts we covered in the notes. So recapping from the last lecture, we talked about the whole process of cellular respiration, starting with glycolysis. And if we don't have enough oxygen to go into the mitochondria and do the citric acid and the electron transport chain where there's lots of ATP production, we're kind of just stuck with glycolysis. What would be some conditions in a patient, do you think, where they'd only have glycolysis occurring because there's not enough oxygen to meet the demands of the cells? What? COPD, that's probably the number one, is bad lungs, right? Bad lungs from a lifetime of smoking. We have a lot of people that smoked in their younger years, and there's so much damage done now, we can't fix it. COPD emphysema is unrepairable. All we can do is treat the lung tissue that they have left, which means oxygen, lots of breathing treatments, lots of inhalers, and their quality of life is significantly diminished because of just not having enough functional alveoli to move gases. So as a result of that, when we're only dependent on glycolysis, how many ATP are we getting per glucose molecule? 2. So that's not enough to really meet demands of working muscles. So people get very short of breath just moving from one side of the room to the other, depending how bad their emphysema is. So it's really a motivator for doctors to educate their patients who smoke and tell them to knock it off while you still can, while you have functional alveoli, right? Because the process of damage to alveoli begins when people first start smoking. But we have so many alveoli, we don't see the damage until we've lost so many. Then we start to feel the shortness of breath and all that kind of stuff. So it's kind of a gradual process. So being dependent on glycolysis, how do people's muscles feel as they're moving across the room to go to the bathroom? Not only are they feeling short of breath because they're not having enough oxygen demand, so that kicks off the medulla to increase the respiratory rate. How do their muscles feel as they're moving from point A to point B? Weak, burning, right? Because the lactic acid production, when we're stuck with glycolysis, we can't move into the mitochondria and get all that really good ATP production. So cellular respiration is an important process for all cells to make energy. What are the byproducts of cellular respiration? What are the waste products at the end? Carbon dioxide and water. Carbon dioxide and water. Now, the bad part about carbon dioxide, the good part is carbon dioxide contributes to our pH in our blood. And do you remember what the pH of blood is? 7.35 to 7.45. It's a very narrow range, so we need just enough, and that's slightly acidic or basic. It's slightly basic because it's over 7. So that carbon dioxide is really good for maintaining our pH, but if we get too much carbon dioxide, what we find is carbon dioxide, when it combines with water, it's a weak acid, and some of it will break up into ions, and one of those ions is hydrogen ion. And what does hydrogen ion do to pH? Drops pH, right? Because pH is a measurement of hydrogen ion concentration, and the pH value represents the negative exponent on that 10. So if I have a hydrogen ion concentration of 1 times 10 to the negative 2, that means I have a pH of 2. We take the exponent on the 10 for the hydrogen ion concentration telling me my pH. So if I have 1 times 10 to the negative 4, what is my pH? 4. So which is a bigger number of hydrogen ions, 1 times 10 to the negative 2 or 1 times 10 to the negative 4? The negative 4 is, or the negative 2 is a bigger number, right? Because if I convert that to a decimal, that's 0.01, right? So 0.01 is 10 to the negative 2, and 0.001, do my math, 0.0030 zeros with a 1 is 10 to the negative 4. So that's a big difference in concentration, right? So just remember that number of pH of 2 represents the exponent on the concentration of that hydrogen ion. So how much more acidic is a pH of 2 compared to pH of 4? If I look at the decimal of 0.01 compared to 0.0001. 100 times, yeah. So the pH of 2 is has 100 times more hydrogen ion than a pH of 4. So when we add hydrogen ion to the system in the body, we contribute to a lower pH. So what happens is when carbon dioxide, we have too much in our blood, some of that carbon dioxide is converted to carbonic acid, which breaks up into ions and releases hydrogen ion. So when we have trapped CO2, which happens with emphysema, right, because there's not enough alveoli, there's not enough surface area to allow that carbon dioxide that's produced, there's not enough surface area to blow that off and have that enter the lungs from the blood to be exhaled. So carbon dioxide builds up and pH drops. And when pH drops in patients, they get really lethargic and sleepy. Really, really lethargic and sleepy. So when you go into a patient's room, we kind of talked about this last time, right? If you have a really sleepy patient, you're going to think blood sugar, oxygen levels, how much pain meds have they been given that day. And if all those are ruled out, then you have to think about what is their lung function. Do they have a major lung problem? If they do, the doctor's going to order a blood gas. And blood gases measure blood pH and the amount of carbonic acid in their blood and other factors. We'll talk about that more at the end of the semester, but I'm introducing it now because I want you to understand that this carbon dioxide produced from metabolism has a role in balancing our pH, but if it builds up, it does major damage and contributes to a condition called acidosis. And acidosis is very serious, and it's probably the #1 reason we see a majority of the patients on our floor, the cardiopulmonary floor, is too much carbon dioxide. And then we have to put a face mask on them. Have you ever seen that? Those of you that work in the hospital, it's called a BiPAP. It's a full face mask, and it helps them get rid of that excess carbon dioxide. And it's amazing. They'll come in totally lethargic, unable to respond. We put that BiPAP on for a few hours, and the CO2 levels decrease, pH raises, and they can talk to us again. But we can't keep doing that, right? So we have to make sure that they're using their inhalers and getting the breathing treatments and doing all the right things. So we have to be careful, too, with patients that are lung patients. We don't want too much activity, because if their lungs can't match that activity, they're not going to be able to blow off that CO2 that's produced from that metabolism. So when people are overly active with CO2, their oxygen levels are going down, but their CO2 levels are raising. So CO2 comes from metabolism, and the more active we are, the more CO2 we have. And that's the #1 driver of breathing. When you're exercising, when you first start exercising, just movement of your limbs causes increased respiratory rate, but once that's complete and you're already moving and going on the treadmill or bike or whatever, it's increased carbon dioxide from the extra muscle activity that stimulates your heavy breathing, because that we need to blow off because it's a byproduct of metabolism. So we talked about angina. So now we're going to go into how the body meets demands, makes this ATP, or releases it depending on the nutrition and nutrients that are coming in or the activity of the individual. So first we're going to talk about sugar. How do we use sugar? How do we get it into our blood? And how do we store it? So the major storage molecule for excess glucose in the blood is called glycogenesis. Glycogen is the molecule that we're trying to create. So genesis means to make. So we're making glycogen when we have excess glucose in our blood. And excess glucose in our blood is when you've just eaten lunch and you've met the demands of your metabolism at that moment, and there's excess glucose floating around. So now that's going to enter glycogen stores. And glycogen is stored in the liver and the muscle. So the liver is going to store that excess glucose as glycogen, and the muscles are going to store it. Now, muscles that are developed, people that do weight training, have more developed muscles, more active muscles, more glycogen stores in their muscles. So that glucose from the blood is going to go into those muscles, into those glycogen stores. Have you heard, that some people that are trying to lose weight, they'll say focus less on cardio and do some weight training to lose weight because it boosts your metabolism? It does, because you're creating glycogen stores for that glucose to go into rather than being stored as fat. So people that lift weights alone, and that's not what I'm recommending because it's good to keep your heart and lungs in shape, but if you just lifted weights alone, that creates glycogen stores, brings excess glucose into those glycogen stores unless it's stored as fat. So you have a higher resting metabolism because of those more active muscle cells that have more actin and myosin. Now remember, we don't get more muscle cells, right, when we lift weights. We only get larger muscle cells with more metabolic activity going on because there's more actin and myosin and all those contracting units. So glycogenesis is making glycogen from glucose, from excess glucose from our diet. Glycogenolysis then is the opposite. It's when we're exercising, person who's trained well, right? So they have stored glycogen in their muscles, like someone who's training as a runner and is going to run a half marathon or do a bike race. Because they've been training, they have these glycogen stores. So when their blood glucose goes down, the liver and the muscle will release glucose. It'll break down glycogen and release glucose to the blood to make ATP during that activity. So what happens to someone who's not trained, who says, hey, let's run this turkey trot on Thanksgiving morning. I'm going to be in town. I'm not trained. Let's go do it. What happens? How does that person feel compared to the person who's trained? They're going to run out of energy, right? They're going to run out of glucose because they don't have the glycogen stores. So it's going to be harder for them to keep up than someone who's trained, because that's the benefit of training, is we're building glycogen stores by working those muscles, and the body adapts to the demands we place on it. So when we stimulate the body with exercise, the body responds by building these glycogen stores. Okay, so why do the liver and muscle cells, why are they able to take glycogen and break it back to glucose, reverse that reaction? Because they have the proper enzymes, right? So they have the proper enzymes. Liver and muscle cells are able to reduce that. Intestinal cells do as well, but we're not going to talk about that. We're focusing mostly on activity in muscle and liver. So now if there is no glucose in the blood, glycogen stores are depleted, so liver and muscle have given all they can give, then we switch into what's called gluconeogenesis. The body, the liver, has the enzymes to convert proteins and fats to glucose to feed the body with fuel. So glycerol comes from from triglycerides, fatty acids and glycerol. And amino acids come from proteins, right? So we can use those to enter the Krebs cycle and convert that to glucose, or to ATP, I should say, not to glucose, but well, originally to glucose, but ATP is what we're looking for, right? So the end product is ATP. So this is important when we are not eating. We're not going to crash and pass out. We can feed the brain with glucose because the liver is going to produce this glucose from these amino acids and glycerol. So gluconeogenesis is what People who are on a ketogenic diet, this is how they function. This is what they rely on, is this gluconeogenesis. And there's other things occurring at the same time, but that's one of the processes that occurs. So the liver is the boss organ when it comes to storing glycogen or breaking it down to release glucose. So here we can see we have glycogen being stored, but it's broken down in the process of glycogenolysis to release glucose to the blood, and then it goes to the brain. Now, if we have fatty acids broken down by beta oxidation, we're going to talk about that. We can release ketone bodies, and that's another way that we get energy, because that also can fuel brain activity. And this is the one that really dominates in people that do the ketogenic diet, because fatty acids are actually preferred as a nutrient source. But when we have glucose available, that's another pathway to energy production. So this really summarizes a lot of the processes we're going to talk about. But when we look at muscle cells, they can use fatty acids for energy, and we'll talk about that when we get into how fat is used. So glycolysis, just remembering our definitions, glycolysis, we talked about that's taking glucose and breaking it into pyruvic acid, right? That occurs in the cytoplasm. Glycogenesis occurs where? And muscles, liver and muscles. So this is where we're making glycogen from excess glucose. And then glycogenolysis is taking, when would glycogenolysis, give me an example of when that would occur. Let's start from the beginning. When would glycogenesis occur? What is a person doing? Just give me an example of what someone's doing when glycogenesis is occurring. Okay, when they're eating, as far as activity levels, what are they doing? Low activity. Sitting there watching TV, right, after a meal, glycogenolysis would be dominating. I'm sorry, glycogenesis would be dominating. Glycogenolysis, the key word to focus on or the key part, that's that suffix, lysis. Lysis means to slice and dice, to break down. So we're taking glycogen and we're breaking it down. What's an example of an activity where that might be dominating? Yeah, high activity, low blood sugar. Yep, yep. Okay, and then gluconeogenesis. When would that be dominating? When you're on a ketogenic diet. When else? Fasting. Yep, starvation. Yep, because people lose muscle, right? When they're not eating enough, they lose fat and muscle because it's being broken down to create glucose. So those are the carbohydrate reactions. Notice that they all begin with glyco. So glyco means sugar, but focus on what's on the end. Lysis, breaking down glucose. Glycogenesis, making glycogen. Glycogenolysis, breaking down glycogen. Don't confuse the first one and the third one, because this is breaking down glycogen, which is the larger molecule, where glycolysis is breaking down just that simple sugar of glucose in cellular respiration. Okay, so now we're going to talk about how we break down fats. Fats we bring into the body as triglycerides. So triglycerides are fats we bring in the form of butter, cheese, or dairy products. Those are all triglycerides made up of glycerol and fatty acids. Body fat that's under the skin of humans are triglycerides. Okay, so when we eat animal sources that have fat associated with them, which they all do, we're eating triglycerides to make triglycerides. So we're breaking it down, and then whatever is left, excess, we store. So we break it down with the help of lipase. Lipase is an important pancreatic enzyme. So lipase is produced in the pancreas. So if a person has pancreatic cancer, what happens to people with pancreatic cancer? They can't break down these fats, so they have unusual bowel movements that have a large amount of undigested fats. people with cystic fibrosis that have mucus-clogged ducts from the pancreas also have these fatty bowel movements that are unusual, foul-smelling because of undigested fats, and they're losing weight rapidly, right? Because they're not getting any energy from the fats that they're eating. So broken down into glycerol and fatty acids. And with the help of the glycerol, there's enzymes again that break that by it enters into glycolysis, and we can take that glycerol and make pyruvic acid. And as long as we have pyruvic acid, we can enter what cycle? We don't need to enter glycolysis because it's already done. We've got the pyruvic acid. Krebs cycle. Yep. So that enters into the mitochondria, is converted to acetyl coenzyme A, and we're good to go. So together, glycerol and fatty acids contribute to the conversion of those molecules to acetyl coenzyme A, and we're ready to run into the Krebs cycle and get our ATP, right? Notice we have the coenzymes, right, that are adding a hydrogen as we break those fatty acids down. So lipogenesis is the opposite now. We're making fat, we're making triglycerides when we have excess ATP and glucose levels. So when we make all the ATP that our cells need, and we have excess, and we have excess glucose, we don't need to enter into the Krebs cycle and ETC, we're going to store this as fat, as these triglycerides. So 50% is stored as fat under the skin, and 50% is stored elsewhere. And where else would we store them? Say what? Say. Okay, such as? Mm-hmm. Yep. We have fat packed around the kidneys. That's what holds them kind of in place because there's not much to hold them in place. So we have fat packed around the kidneys. We have fat packed around the eyeball. Do you ever notice after like a bad stomach flu or rapid weight loss related to something, you look really sunken in your eyes? It's because that's a ready source of fat there. People look really hollowed out in the eyes when they've lost a lot of fat. But we also need fat where? Where do we need, what do we need some of the parts of triglycerides for? Do you know? Two fatty acid tails are on this really important structural feature of our cells. Yeah, the plasma membrane, phospholipids. So some of those fats are going to be needed for making new cells, right? And some of our hormones are lipids, like the sex hormones, testosterone, estrogen, progesterone, cortisol, cortisone we call it in the clinical environment when we make it artificially. But those are important fatty hormones. So we're going to use it for other things as well. But the most, a good majority, well, not majority, but half of it, enough to cause trouble, right? Because we have an obesity epidemic in the United States, is stored as fat, as adipose. Because we never want to lose excess glucose. Anytime there's excess glucose in the blood, we're going to store it somewhere. We're not going to urinate it away or excrete it, because the body is always preparing for famine. That's our way of surviving. That's the way that we've developed to survive in any environment. So if there's excess calories on board, we're going to store it as fat. Okay. So when would lipogenesis, what's the state in which we would see lipogenesis occurring? What's the body doing when lipogenesis is happening? Yeah, sedentary, sitting after a meal, taking in more calories than we're using, which happens at the holidays, right? Thanksgiving, Christmas, those holidays back to back are really tough. I know I'm struggling with that right now. I'm hanging on to extra weight from the holidays. I look in my closet and I'm like, well, I can't wear that, can't wear that, can't wear that. But I'm working on it. I'm exercising again. I'm trying to up my metabolism to burn off that excess fat. Okay, so lipolysis then is the opposite reaction. So it's the reverse of lipogenesis. And we're going to break down those triglycerides into what two components again? What are we going to release? Glycerol and fatty acids. So this is what happens in the ketogenic diet. And when we have fat and protein in the diet. There is no carbohydrate oxidation, so we're going to go into ketogenesis, where we use those fatty acids which produce ketone bodies. But that's okay for the average person who has a healthy liver and kidneys, because the kidneys are working extra hard on breaking down those proteins that are in the diet. So it's important that we keep in mind that the ketogenic diet is not for everybody. It's not for people that are older that have reduced kidney function. Like, I have some family members that are in their 70s that are doing the ketogenic diet, and it's not really recommended for people that are older with, just more sluggish kidneys as we age. That's one thing we really can't avoid, is the aging effect, the loss of functional nephrons in our kidneys. It's just an aspect of aging. So we have to be smart as people age and educate them about that. Medicines, they don't need as much medicine when it comes to like pain medicines. It's not going to break down as quickly in elderly people. We have to be aware of that. So we have this acetyl coenzyme A that can build up in the blood as these fatty acids and glycerol are broken down, and then that's converted to these ketones. And it's excess, so where are we going to find them? How can we test to see if someone is in ketoacidosis or ketosis? Yep, in the blood or urine, we're going to see excess ketone bodies. In the urine is where we're going to see it primarily, is where we would test and say there's excess, right? Because it's spilling out into the urine. And that's what some people that are on the ketogenic diet, they actually buy urine test strips and they test their urine to make sure they're in ketosis. Because some people enter in ketosis with a little bit of a carbohydrate in their diet, but mostly fats and proteins as their major energy source in food. So other people have to have like almost no carbohydrates to get into ketosis. So everybody's a little different of when they enter into this state of ketosis, where that's their primary source of energy, and they just have to test their urine to see if they're in it or not. But when these ketone bodies, they're called acetoacetic acid, beta-hydroxybutyric acid, and acetone. Anybody know any one of those? One of those is a familiar product. Acetone. What do we use acetone for? Remove paint. Typical male response. The ladies, what? Nail polish remover. Yeah, exactly. So when you mix acetone in the blood along with high blood sugar, the exhale on a patient that is in diabetic ketoacidosis, which is a dangerous state of ketosis when there's no insulin, it smells like juicy fruit gum. Do you know the smell of juicy fruit gum, that cheap gum from years ago? It has a sweet, kind of fumed aroma. And a doctor can enter a small exam room in an ER and recognize that right off the bat based on their exhale. They know that we have got a diabetic in ketoacidosis, which is dangerous. And that person has to go to critical care and be put on an insulin drip, because that means blood sugar is really, really high and has been high for a while. And there's no insulin, so the cells are starving, and they're switching over to what? For energy. What? Fats and proteins. It's not the preferred, but we do break down protein if the body has to, right? People know that they're going to lose muscle if they don't eat enough, right? And that's why we have to be careful when we're dieting to not cut our calories too strict, because metabolism slows down, muscle breaks down, and that's not healthy weight loss. It looks like weight loss on the scale. We lose water weight too, because we're not bringing in as much water. People feel like they're losing weight, but they're not actually losing fat. They're losing muscle, and they're slowing their metabolism down, which means they have less energy. So the best way to lose weight is to reduce the bad calories, right? But up your activity, increase the metabolism. Dieting without exercise, is really a joke, in my opinion, because it's not sustainable to constantly, deprive the body of food where you're always hungry all the time. Okay, so lipolysis then. A state of lipolysis would be starvation, right? Excess activity. We're going to be breaking down fat. So when people are on the treadmill and they're working hard, but not so hard that they're breaking down muscle and damaging the body, because that happens when people exercise. say, get on the treadmill and run a 7-minute mile before they're ready for that, that's damaging to the body and actually breaks down the body and is not good for developing good cardiovascular fitness and burning fat. Did you ever notice on the machine sometimes it'll say the fat burning zone and the heart rate of the fat burning zone? There is a zone of where your heart rate should be where you're primarily relying on fat breakdown, not into muscle breakdown. Because how do people feel when they run really fast on a treadmill? How do they feel the next day? Sore muscles, right? Because the muscles have broken down as a result of that intense exercise. So lower level exercise where you're not huffing and puffing and struggling to keep your muscles going, that's when we're burning fat. And that's what people don't realize. We think we have to suffer to lose weight. We really don't have to suffer where you're huffing and puffing and feeling miserable. You have to be slightly breathing a little faster, but not to the point where you're gasping for breath. Okay, so this is just a nice little flow chart that shows, notice these reversible reactions. So again, enzymes are required to reverse these reactions. So we have fats, right, that are stored in adipose tissue, and those fats are triglycerides, or they come in from our diet. So we can break them down by lipolysis into glycerol and fatty acids. And that glycerol is converted to pyruvic acid. The fatty acids are broken down to contribute to acetyl coenzyme A production. And then we enter the Krebs cycle. And we have that ATP production that we need to sustain life, right, and get a lot of energy. But then we also have cholesterol that is released, and that breaks down into steroids and bile salts. Do you remember what steroids are? What? Yeah, steroids are a fatty molecule. It's the basis of hormone production, so cholesterol. It has that 2-ring structure, and we use it for making all of our fatty hormones, so it's really important. And remember that cholesterol is found in the plasma membrane. It stiffens the plasma membrane so it doesn't break apart, because phospholipids, which are the basic structure, those are oily, and they would just fall apart. But with cholesterol inserted in there, it gives the cell membrane integrity and keeps it intact. So we need some cholesterol. But if we have too much fat production, if someone's on a rapid weight loss plan, and they're dumping a lot of cholesterol and bile salts into the blood, what can that contribute to? High cholesterol, for one, which can clog arteries and cause trouble. But bile salts can contribute to gallbladder, stones in the gallbladder, and that can cause gallbladder disease. So who's at risk for gallbladder disease? Is anybody with excess triglycerides in the body is at risk for gallbladder. So people that have excess body fat are primarily at risk for gallbladder disease. So we find it's more common in women over the age of 40 that have been overweight most of their life because of the chronic circulating bile salts. They form stones and they clog up in the gallbladder. They block the ducts going from the gallbladder to the duodenum. Remember, we have the common bile duct, right? And the cystic duct coming from the gallbladder, it gets stuck in there. And then people feel a lot of pain after meals. And it's all about, how we digest fats. Okay, so beta oxidation then is the breaking down of fatty acids to form acetyl coenzyme A. And again, lipolysis is where we break down that glycerol to pyruvic acid. So summarizing those reactions, beta oxidation, fatty acid, acetyl coenzyme A. And again, where does acetyl coenzyme A get used? Where are we jumping into the cellular respiration pathway? Krebs cycle. Remember, that's the first molecule to enter the Krebs cycle. And then lipolysis, breaking down lipids to fatty acids and glycerol. That happens in our fat cells. And lipogenesis is taking the excess breakdown products of glucose and putting that, making fat. So lipogenesis, when we're sitting around, lipolysis, when we're not getting enough food, starving, low-carb diet, ketogenic diet, diabetic ketoacidosis. And then lastly, the protein reaction. So we can also use proteins for energy. There's 2 processes. So if we look at transamination, is when you take an amino acid and a keto acid, and where did the keto acid come from? And where did that come from? Okay, what was it produced from? Where do we, yeah, we look at back at the keto acids that I mentioned, those three here. So when we break down fat, we form these ketone bodies, keto acids, okay? So back here, so we take the amino acids, keto acids, we form ammonia, which is then converted to urea, which is excreted by the kidneys. So this ammonia can be damaging. Ammonia, when it builds up in the blood, causes brain dysfunction because ammonium ion is a base, and that's going to do what to pH? What do bases do to pH? Raises it, yeah. So when ammonia builds up, the liver takes care of it, though. The liver converts it to urea, right? So the liver converts it to urea. It's excreted by the kidneys. But what happens to someone who is an alcoholic, lifetime heavy alcoholic, and their liver is shot? What happens to ammonia when they're breaking down protein? It just builds up in the blood. And now they act like they have dementia. So we have people that come in to the ER that have been found passed out in their home for days, brought in by a family member or a neighbor, and they have a lot of fluid build up because of damage to the liver, and that's a whole nother issue we'll talk about later. But the liver's shot, so when they eat proteins, when they eat a turkey sandwich, that turkey is broken down into these keto acids, or sorry, into the amino acids, which then are converted to ammonia, but it builds up because the liver can't convert it to urea. And then we have to give them a medicine to get that ammonia out of their blood. So actually what we, and this is the unfortunate part about caring for someone that comes in with this severe alcoholism and built up ammonia, is the only way to get rid of the ammonia. It's not like carbon dioxide. We can put a mask on and just kind of draw it out with the mask, right, with changing pressures. We have to get that ammonia out by drawing it into the digestive tract. So there's a special laxative we give them that pulls it out of the blood, and they essentially poop it away with lots of diarrhea. So isn't that fun, right, for that patient, that that's how we get the ammonia out, is they're on the toilet and just pooping that away. So it's a mess. Those people are miserable when they come in, and we have to give them good care and make sure you prepare them that to get these ammonia levels down, we're going to give you this medicine called Kayexalate, and it's going to get the bowels moving. So be happy you have a functional liver that's converting that ammonia to urea, sent to the kidneys, and the kidneys excrete it. Then the keto acids are used entering the Krebs cycle, and again, we have ATP production. So the keto acids are used to make ATP instead of glucose. And that's oxidative deamination is what we call the process of taking the amino acids, converting it to ammonia, and then urea. And then transamination is the formation of these keto acids from the keto acid that was originally produced in the liver. So this kind of summarizes how we use these nutrient sources. And if you look at all the arrows, what do they eventually lead to? What's the molecule that they can all produce? At the end of the day, ATP, yes, but along the way, how do they all can enter the Krebs cycle, right? So we're skipping glycolysis here. And what are we entering? What do we have to produce to enter the Krebs cycle? And yeah, so it's all about acetyl coenzyme A at the end of the day. All of these fuel sources result in acetyl coenzyme A, and we enter into the citric acid cycle and get that good ATP production from the help of the electron transport chain. Okay, so we talked about the accumulation of ketone bodies is called ketosis, and we see this in starvation, unwise dieting, which again means you're not bringing in any carbs and you're not bringing in enough calories, or in diabetes. But in the case of diabetes, what happens is when there's no insulin, we have too much fatty acid metabolism, and I'm going to show you a brief video on that process. We end up with a really low pH, this fruity breath, and reduced cognitive function, really sleepy and tired and miserable. And the body tries to get rid of the excess acid through the respiratory tract, because when we have a buildup of carbon dioxide, that can, again, lead to carbonic acid. And the way that we get rid of that, like when we're exercising, we're building up CO2, could potentially have excess carbon dioxide or carbonic acid, but we breathe heavily, and that's how we get rid of it. We blow it off by breathing heavily with exercise. But if we have excess ketone bodies, which causes acidic conditions in the body sees it the same way and tries to blow it off through the respiratory tract. They see it as acid conditions, and let's blow this off. So a person with diabetic ketoacidosis has this deep, heavy breathing, but they're at rest. And that's another sign. The doctor will come in if he sees a patient sitting there really lethargic, has this weird breath, and they're breathing like, they're not doing that, voluntarily. They're doing it as a result of the body trying to blow off that excess. Okay, so I have a video I want to show you. There's a big difference between ketosis in a healthy person with good insulin production and ketoacidosis in a diabetic, type 1 diabetic, where the pancreas is damaged by some autoimmune disorder or dysfunction and causes them not to be able to secrete insulin. So we're going to look at the role of insulin and how this diabetic ketoacidosis kicks off in diabetic patients, or patients with diabetes, we should say.
Cram. Okay, well, welcome to another MedCram lecture. We're going to talk about diabetic ketoacidosis, DKA. Now, DKA is a pretty significant illness. It accounts for about 130.
It's the fluid of the mitochondria. So those are the key concepts to remember with ketoacidosis. So the difference between someone on a ketogenic diet is what? How would you explain what is different from a diabetic who's in ketoacidosis? Why does a person on the ketogenic diet not go into ketoacidosis? They have insulin. So what does insulin do then, did he say? Yeah, it prevents that beta oxidation of fatty acids. So the diabetic patient has excess fatty acid metabolism going on. And what does beta oxidation produce? Those keto acids, right? The keto acids, the acetone is the big one that we smell on the breath. So when we have excess fatty acid beta oxidation for energy, that's when we dip into ketoacidosis and dangerous levels in the pH, right? Dropping of the pH. But in the person on the ketogenic diet, they have some beta oxidation, but they also have glucose being used as well. Again, by what process does glucose enter the blood? Because they're not eating glucose. What are the three major processes of glucose metabolism? Look on that list. It had the bread and the... What process is occurring that's making glucose and using it? Yeah, gluconeogenesis. So gluconeogenesis is happening in the diabetic, but is it helping them any? If the glucose can't enter the cell because there's no insulin? No, it's just contributing to higher blood sugar yet, right? So what does a patient with diabetic ketoacidosis look like if we look at their symptoms? When they're newly diagnosed is when we see most people with diabetic ketoacidosis. It's usually a young person, could be a child, or a college-age person. It's more common in younger people. But they're going to come in with fruity breath, really high blood sugar, a lot of, really lethargic, heavy breathing, right? And when there's so much glucose in the blood, and we're not in the kidney, and that blood enters the kidneys, and the job of the kidneys is to filter the blood and take the good stuff out and put it back in the bloodstream, right? Again, we never spare glucose. We never get rid of it. We always store it, right? But if there's so much entering the kidneys, the transporters for glucose to take glucose out of the blood or out of the urine and put it back into the blood, they're maximized. The transport maximum is exceeded in people with diabetes. So what happens is the excess glucose can't be transported back to the blood, and it ends up in the urine. So sugar in the urine is another classic symptom of a person with diabetes. They don't even need to be in acidosis. Even just chronically high blood sugars can cause that. So we look at that as well. And if you're peeing extra because all that sugar in the urine draws water by osmosis, so now they have this large volume of urine production, what is that going to lead to? What's another sign that they're going to have? Dehydration, yeah, dry, sticky mouth. That's another symptom of diabetic ketoacidosis. So we got to fix all of these things so they can lead to death. And I've taken care of patients that don't manage their diabetes. And who do you think those people are? Type 1 diabetics that don't manage their diabetes. What do you think is going on at home? Kids and young people. Right? Not compliant, not checking their blood sugars. What do you think their parents are like when you're talking young children? Not paying attention, not following the doctor's orders, kind of maybe dysfunctional lifestyles. I had a patient, being an on-call nurse, sometimes I get the difficult patients when I come onto a floor because everybody's burnt out, right? They've got this difficult patient, maybe they're angry and nasty and calling everybody foul names, and then I come on and like, well, we're going to assign you to this room. And I'm okay with that, honestly, because I'm fresh. I'm not burnt out from working 40 hours and dealing with difficult patients, and my back is sore and my knees hurt. I come in, I'm okay with that. Give those nurses a break. That's perfectly fine with me. So I came in, they said, be careful, we got a really angry patient. He was in his early 30s, missing his legs from the knee down, blind from the uncontrolled diabetes. So blind, missing his legs from the knee down, and on dialysis because his kidneys were also damaged from uncontrolled diabetes. And he's refusing to take his medicine, and he's calling the nurses any foul name. The worst foul names you can think of is what he's calling his nurses. So good luck. His meds are about 3 hours overdue, and he's really angry. Like, okay. So I go in and I introduce myself. Now, he can't see me, so he doesn't know who I am or what my body language is like. So I try to show it in my voice, and just talking to him. And, I just told him, seems like you're having a really bad day today. And, what's going on? And I sat down. And I sat down at his level. So he's laying in the bed, and he knows I'm sitting because his ears are working fine. He knows I'm sitting. So right there, I think I was showing him that I'm going to take the time and see you as a person and not just a mess of complications from uncontrolled diabetes, right? So I sat down. He's just staring straight ahead because he can't see me. And I just talked to him, and I just asked him, what's going on? Why are you so angry? Well, it doesn't matter. It doesn't matter. I don't care. I'm not going to take the pills. I don't care. Nobody cares about me. I don't care about anybody else. I just want to die, so I'm not taking any of the pills. And I said, well, how are you feeling right now? Are you in pain? Yes, I'm in pain. What do you think? I'm miserable. I've got a really bad headache. I want everybody to just leave me alone. And I said, well, 2 of the medicines I have in here are pain relievers. So if you took those, it would help your pain. And at least, I understand what you're saying, but if you at least took these pain medicines, you wouldn't be miserable laying here. Maybe you could turn on the TV and just pass the time, but you wouldn't be miserable because headaches are terrible. All right, I'll take the pain meds. So I give him pain meds. And then we talk. And then here's his story. So here's what he told me. One, his mother rejected him as a young child. She lived a dysfunctional lifestyle, had no time for her kids, and acted like she didn't like him, called him foul names, treated him really poorly. They lived in Chicago, so he joined a gang. So as a member of a gang, he felt like he was part of something, like people appreciated him and cared about him, so that was his family. And they made a lot of money. He sold drugs and made a lot of money. And with the money that he had, he said, I loved to buy candy and junk food because I never had it growing up. So I would buy candy and junk food. My blood sugar would go through the roof, and I'd be passed out on the sidewalk. Someone would find me, and I'd be in diabetic ketoacidosis. They would take me to the hospital, get me all fixed up, but I didn't care. Nobody cared about me. All I cared about was drugs, gang, and eating my junk food and candy. So I went back on the street, and I'd do it all again. He said, because nobody cares about me, I don't care about myself. And then he started to cry and said, that his mother still doesn't care about him, never calls to see how he's doing, and he just, has no reason to live. He said, but when he was in high school, before this all started, he said he was on a good path in early high school and was a wrestler, and a really talented wrestler. So he was giving me advice for my one son that was wrestling at the time and telling me about these moves and all this kind of stuff. But at the end of the day, so then as we're having this conversation, I said, yeah, your blood pressure is really high. I said, that's probably contributing to your headache that you're having right now. Do you want to take this blood pressure medicine? And he's like, well, yeah, I suppose that makes sense. I'll take that. So I gave him the blood pressure medicine, got that in, and those were the 2 medicines he really needed, were the blood pressure and by the end of the conversation, the end of my shift, he was friendly and he wasn't angry because we took the time to listen to his story and to understand why he got to that state. Because when you look at a patient at the end of all their life choices, we tend to judge, right? We look at them and say, oh my gosh, you're a mess, you're angry, look at what you've done to yourself, and now I got to deal with this stuff. But you just don't know their background. Some people can cope with loss, like the loss of a parent's affection. Some people can cope with that. Other people can't. It's just all personality, right? Some of you know maybe relatives, friends, siblings. Some are great and have overcome obstacles. Some can't. This was a guy that couldn't overcome his obstacles of his lifestyle. So as a result, he ended up with damage to all these major organs because high blood sugars increase blood pressure, and high blood sugars damage the tiniest of nerves and the tiniest of blood vessels. So where are the tiniest of nerves and tiniest of blood vessels? The glomerulus is a tiny little tuft of capillaries in the kidneys. When there's chronic hypertension and chronic high blood sugars, it damages the glomeruli, and then the kidneys fail. So that's one. The retina, the choroid layer behind the retina, right? And the retina has tiny little nerve endings and a blood supply. Again, those get damaged by chronically high blood sugars. The nerve endings and the tiny blood vessels in our feet, as a result of gravity, are under subject to high pressure, right? So those get damaged. So what happens when your feet and nerves, the blood vessels and nerves in your feet are damaged? They become numb, right? So when you have numb feet and you're walking across the floor and you step on something sharp, do you know you stepped on it? And this is really true of type 2 diabetics, people that, have high blood sugars from, we know that obesity increases, the more adipose tissue, the higher risk for insulin resistance. So insulin is being secreted, but the cells are resistant to it. So as they develop type 2 diabetes and they don't watch their blood sugars because they're not paying attention to it, they think that, the doctors are just like, yeah, I know, I've got high blood sugar, whatever. So they don't pay attention to it, and then they start to get numb, tingly feet. Numbness is the final result of damaged, dead nerves, right? They step on something sharp, they have a cut on the bottom of their foot. If they're morbidly obese, are they looking at the bottom of their feet on a regular basis? No. So what happens, pretty soon they come in sick, and they're sick everywhere, like fever, chills, lethargic. We do a blood test. Yes, they're septic, which means you have bacteria in the blood. And we look for the source, look at the bottom of the foot, and there's a big wound on the bottom of their foot from something they stepped on maybe a month ago. We had one lady come in the last year, one of my patients. She stepped on a needle, and she had a needle in her foot and didn't know it. They did an x-ray, and they found a fragment of a needle in the bottom of her foot. And she said, I knew that thing fell off my dresser. My cat pushed it off, and I couldn't find that darn thing, so I must have stepped on it and not known it. And she had major infection because of it. So how does the body heal in the legs and the feet if the blood vessels are damaged? How do we heal infection if there's no blood flow there? We can't, right? So that's what happens is people get these sores, like even on the skin, because of poor blood flow and damage. They get sores on the surface of their skin, and then they can't heal. And as a result, we try to cut it away and try to heal it by using surgical techniques. But eventually, it comes to a point of where you either have to remove the lower leg or they're going to die and they're going to have infections, system-wide. So that's why they lose a limb. And people also lose limbs from knee replacements gone bad. What happens to a sugary environment, a person with a sugary environment with uncontrolled blood sugar, and they go in for a hip or knee replacement? The chance of infection just from a hip and knee replacement is really high because you're putting artificial parts into the body. Now you have a high sugary environment. So if you have some bacteria in the environment, that sugar environment increases the risk for infection. So people with type 2 diabetes have type 2 diabetes from a life of obesity. So they're going to need the hip and knee replacements, but they got to control their blood sugar. So the biggest thing we can do as caretakers of people with diabetes is tell them to control their blood sugar. I have a relative who's had type 1 diabetes since she was 16. She's now in her late 60s. She has full function of her eyes, her kidneys, her skin. She controls her blood sugar very tightly. So if someone you know doesn't, what are some options for them? What's a good way to control blood sugar if you have a kid or a person who is not controlling their blood sugars? Do you know what device is a good device? Yeah, the insulin pump is a good way for active people that don't want to mess with their blood sugar as often. They still have to do some monitoring, but the pump can really cover a lot of things because it's hard. I mean, picture some of you guys that are in your early 20s and you're going from here to there and place to place. How would you like to have to drag insulin everywhere you go and your glucose monitor and be poking your finger several times a day, and everything you put in your mouth you have to think about? Now think about a person that's kind of dysfunctional, a person that doesn't have a lot of hope. They don't want to spend the time to check for blood sugars, and as a result, they end up in the hospital. So you're going to find, when you get into healthcare, a majority of your patients are going to have blood sugar issues. It's, in my opinion, I think it's the next silent killer next to high blood pressure, and it even causes high blood pressure. So we have to tell people to control their blood sugars. And I hear young CNAs that are overweight tell me on their floor, I'll overhear them talking, yeah, my doctor said I have pre-diabetes. That's dangerous. When a person is in their 20s and has high blood sugar, that means we need to get that fixed before it tips into full-blown type 2 diabetes, and then they're going to start to have these symptoms if they don't get it under control. So we can't emphasize enough the influence of high blood sugars on homeostasis in the body. So that concludes the cellular metabolism lecture. Your lecture quiz will be on the notes, starting with cellular respiration, then ending with the last note on ketoacidosis and ketosis.